Hello there everyone, my name is Udit and in today's video I'll be talking on algorithm. So in computer science, an algorithm is a finite sequence of well-defined set of instruction which is unambiguous. Unambiguous means no dual meaning. There is only one and only one single meaning to it. Okay. The best example which I can give you and which you can relate probably to your daily life is maps. So like if you select your destination point, then the software like Google Maps automatically analyzes the shortest path and give you somewhat like this kind of instruction where you need to press the start trip button and you get this kind of instruction like 2 kilometer to the right, 1.5 kilometer straight, then 20-meter turn, and then you reach your destination, somewhat like this. Now this is the best example to algorithm, and the reason is it has a finite sequence of instruction and it is well defined. Also it is unambiguous in nature. So algorithm is almost everywhere, and algorithm can be considered as some set of instruction which you can use to reach your destination or to solve a problem. Okay. Now the thing is that okay, I guess the algorithm spelling is wrong. I'm really sorry. Now the thing is that we humans are very smart and we humans can understand algorithm. Okay, we humans can, but the computer cannot understand such languages. The algorithm, they can't understand what algorithm is there, and we need to implement the algorithm using a programming language so that it can be understood by computer and the computer can solve it. Okay. And the languages we use are C, C++, Python, Dart, Java, JavaScript, and there are many more programming languages which is available across the globe. Now in our series we are using C. Now since we know what algorithm is, let's see what are the approaches for designing an algorithm. Okay, so an algorithm, a complex algorithm, when it's divided into smaller units, this kind of technique is called as modularization, in which what we do is basically we divide our complex algorithm in smaller modules and then we solve those individual modules. Okay, this method is also called as modularization. Okay, and the advantages of such approaches are, first of all, it makes the complex algorithm simpler to design and implement, and that's very obvious. If I have a big algorithm to code, then it would be harder for me to code. Rather, if I divide a complex algorithm in smaller modules and work on them individually, it's going to be easier for me to work on them, to design it and implement it. The second thing is each module can be designed independently. That is, if I have divided my complex algorithm say into 4 modules, then I can work on any one of the module without taking into consideration of the other 3 modules. And this is the best thing in this approach to design an algorithm. Now under modularization we have two approaches, and these two approaches are top down approach and the bottom up approach. Okay, so in top down approach what we do is we first write our main function. In general, we write our main function, then we write our user defined functions, and so on. Whereas in bottom approach, this is just the reverse of top down, where we first write user defined functions and then we write the main function. Okay, this kind of approach, the top down approach, is generally followed in POP languages. POP means procedure oriented programming languages. Okay, whereas the bottom up approach is generally followed in OOP languages, object oriented programming languages, and the example are C++, Python, Java, Dart, etc. Whereas the examples are C language. Yeah, The C language is a procedure-oriented programming language. Now, in top-down approach, the basic difference between the top-down approach and the bottom approach is very simple. In top-down approach, what we do is we divide our main function, the working of main function, into smaller module, okay, and then we work on them. Whereas in the bottom-up approach, we try to solve the small problems and then integrate them and get the result. This is the basic difference between top-down approach and the bottom-up approach. Let me show you an example of top-down approach and bottom-up approach. Okay, so here you can see that in this particular code, I have first written my main function and then I have written my user-defined function, that is integer import and the integer add. Okay, so this kind of approach where we first write our main function and then we write the different modules to solve a problem, such kind of approach is called as top-down approach, and this kind of approach is generally followed in procedure-oriented programming languages. Now this is the forward declaration of the function. This is not the definition. This is just that I'm declaring that I have such kind of functions there. Now coming to bottom-up approach, in bottom-up approach we first write the user-defined functions and then I'm going to write my main functions, and this is the basic difference between top-down approach and the bottom-up approach. Now let's come to the three control structure which decide the flow of control. The first is sequence, and the sequence tells that which statement has to be executed next, means which is the next upcoming instruction that has to be executed. The second control flow of control is decision, and this statement is used that when an execution of a process depends on something. Okay, like for example, if I want to execute a particular code only when a number is greater than 0, then at this point I'm going to use if else statement, which is going to basically decide the next statement to be executed. The third is the flow of control. The flow of control of an algorithm is loops, and this statement involves executing one or more steps for a number of times. Like for example, if I want to execute a particular instruction n number of times, then I can do it using loops. And the three types of loop which most of the programming languages give us, they are while, do while, and the for loops. Now what we know is that to solve a particular problem we can have different approach, okay, and each approach is slightly different from others on the basis of the number of resources it is requiring and the time it is taking to execute. So an algorithm, how good an algorithm is basically decided on the basis of how the amount of memory and the time consumed by an algorithm increase with increasing number of inputs. So this is nothing but finding the time and space complexity of an algorithm. In our upcoming video, I'll be discussing on finding the time and space complexity of an algorithm. Thank you for watching this video. If you have any doubts, let me know in the comment section down below.